the inverse of matrix A written as A to the minus 1 like this is such that the product of these two matrices is commutative, which we can write like this, as in the order of the multiplication will get us the same result, and when we multiply them we get an identity matrix. Here, if A is a 2 by 2 matrix, then we end up with a 2 by 2 identity matrix. Sometimes this is written as A by the inverse matrix equals the inverse matrix by A, which equals capital I for the identity matrix. The inverse of a square matrix exists when the determinant of that matrix does not equal 0. In general, if we call the matrix A, B, C, D, as in it has the elements A, B, C and D, then the inverse of that matrix will equal 1 over the determinant of A multiplied by the matrix where we interchange A and D. So we've got D there and A there, and then we change B into negative B and C into negative C. And remember that det A is equal to AD, the product of AD minus BC. That's how you do it. Here we have matrix A is 3, 7, 2, 5. To find the inverse of A, first we find the determinant of A, which is AD, or the product of AD minus the product of BC. And this gives us 15, take away 14, which is 1. And the inverse matrix of A is therefore 1 over the determinant of A, which is 1 over 1, multiplied by the matrix with A and D interchange, so that becomes 5 and that becomes 3, and we have a negative B and a negative C. So final answer, the inverse matrix for our A up here is 5, negative 7, negative 2, 3. If we take another matrix, and we can check this for ourselves as well, if this is correct, then the product of A and the inverse matrix will be 1, 0, 0, 1, and the product of the inverse matrix and matrix A will also be 1, 0, 0, 1. So that's a way of checking whether this is correct. Let's have another example. Matrix B, we'll let that equal 11, 4, 7 and 3. And then we first find the determinant, and in this case the determinant of B is again the product of A and D, which is 11 and 3, minus the product of B and C, which is 4 and 7. So we have 33, take away 28, that gives us 5. And then the inverse of matrix B equals 1 over the determinant of B, which is 1 over 5. And then we put in the matrix, we interchange A and D, so we have 3 in this position and 11 here, and we have a minus B and a minus